Hello, my name is Patricia Morales Bueno. I am a professor at Pontificia Universidad Católica del Perú, and I'm going to present the work Assessment of the Attitudes of Engineering Freshman Students Towards Chemistry Learning using an adaptation of the Colorado Learning Attitudes About Science Survey. It is known that scientific education in many countries is marked by a worrying decline in the interest of young people to pursue scientific careers and a high social rate of scientific illiteracy. For the case of Iberoamerica, some studies have revealed that most students did not have a direct interest in the study of the exact and natural sciences. Although engineering had a better acceptance, the greater tendency was towards the social sciences. The causes that could be affecting the attitudes of rejection are mainly related to pedagogy and education in science. So policies to promote careers linked to science and technology should not be dissociated from the way science is taught and learned. Several authors have analyzed this critical situation. For example, Vasquez and Manacero highlighted the fact that the promotion of favorable attitudes towards science and technology has become priority objective of scientific education. The authors define the attitude as the personal predisposition towards an object, which implies a cognitive dimension, or knowledge of the object, an affective evaluation, and explicit behavior related to the object. The affective evaluation of the object, which can be favorable or unfavorable, is usually the most important component of the attitude because it is determined by the various cognitions or beliefs about the object and usually influences the behavior towards the object, either of approximation pleasure or of rejection dislike. Commonly, chemistry is perceived as the discipline that gives rise to greater students' rejection. Several studies have been reported with the aim of assessing students' attitudes towards science, particularly toward chemistry, especially at the secondary level. The results of these studies suggest that the positive attitude towards science is a complex construct that can be influenced by different factors such as educational level, cultural and social context, and gender. Therefore, the need arises to evaluate this construct in the context in which the educational action is developed. In this way, it will be possible to count on useful information to make curricular decisions to improve these attitudes in students. In this sense, the aim of this study is to assess the attitude towards chemistry and its learning in first-year students of sciences and engineering of a Peruvian university. The instrument used was the Colorado Learning Attitudes About Science Survey (CLASS) for use in chemistry. CLASS was designed to assess students' beliefs about chemistry and their learning by adapting an early version of the instrument designed to assess these attitudes in physics. It consists of 50 items for which a 5-level Likert scale is available, from strongly disagree to strongly agree. For an individual, a favorable score is considered to be the percentage of responses that are in agreement with the expert response. Survey statements are grouped into 9 categories, which encompass only 36 of the total statements. A psychometric study of CLASS demonstrated the convenience of working with reduced versions of the instrument that can be adjusted to simple scales avoiding overlapping of items. In this sense, for the purposes of this study, The instrument was adapted using only the 36 items that make up the categories predicted. It was necessary to translate the survey into Spanish and perform an exploratory factor analysis to identify the category structure of the scale. In addition, reliability analysis was performed through Cronbach's alpha. The participants in this study were first-year engineering students of a Peruvian university who were enrolled in a general chemistry course during the year 2016. Table 1 summarizes the participants' characteristics. Class was administered to the first group of participants at the beginning of the semester. The survey was administered to the second group of participants as pre- and post-test, with 4 months between them. The instrument was available online to facilitate student access and data processing. Class construct validity was estimated by exploratory factor analysis of principal components with orthogonal rotation using a statistical package for the Social Science 21 software. The level alpha was established a priori in 0.05. From the data collected, a descriptive analysis of the scores obtained in class categories and the whole test was performed. To verify significant differences between the results obtained in the pre- and post-test, t-test for related samples was performed. Table 2 shows the descriptive statistics for the 4 optimum categories: personal interest, conceptual learning and problem solving, atomic molecular perspective of chemistry, and making sense and effort. In Table 3, the reliability statistics corresponding to the 4 optimal components obtained for class are shown. The corrected item total and alpha correlation value ranges if the item is removed in each dimension support the proposed factor structure for the scale. Table 4 shows the descriptive statistics for pre- and post-test class scores. The inferential analysis performed with a t-test for related samples showed that the differences between pre- and post-test were not statistically significant in the total score and each category. The results obtained according to gender showed a negative change in the case of males when comparing the total score between the pre- and post-test. In the case of females, the observed change was positive. However, these differences were not statistically significant. Figure 1 on the left shows the results obtained for males in the total score and in the categories. Figure 1 on the right shows the same information for females. The results obtained may be considered good, although it is necessary to continue the study by performing a confirmatory factor analysis for the confirmation of the model. It has been observed what other authors pointed out in relation to that only some of the categories of the original instrument can be replicated in the application in different contexts. However, this fitted well to the proposed interpretations for each factor. The 4 categories identified are relevant to begin exploring the attitudes of first-year chemistry students. These can be complemented with other information such as interviews with students, evaluation of motivation, as well as the use of metacognitive strategies. All this becomes a valuable input for the decision making in the planning and design of the teaching of this discipline. Thank you.